the previous videos, we mentioned about the methodology. This is one of the important chapters in your thesis, providing detailed descriptions of the methods and the materials that you use in order to accomplish your research study. It also provides information regarding your research design, presenting the stages of your research in achieving the objectives of your research study. You will need to plan your research properly, demonstrate good linkage and correlations between different stages of your research. It is important for you to ensure there is no overlapping and redundancy throughout your research design. This is so that you are able to expressively evaluate the output of your research, whether they are attaining to your objectives. With that, you were recommended to use the simplest model, which is one-to-one model. This relationship between different elements of the research needs to be clearly reflected in your thesis, where through your writing, you need to structure the content, implying the structures of one-to-one models. Therefore, in terms of the writing style, I will recommend for the problem statement section, there will be at least 3 paragraphs, each paragraph highlighting one of the sub-problems, in the case that you have 3 objectives. And then when you construct the objective, there will be 3 objectives clearly written. The objective needs to be SMART objective, which are specific, measurable, achievable, realistic, and time-bounded. And then when it comes to the significance of the study, scope of the study, method, analysis, and conclusions, similar structures follow accordingly. It is so that the readers can understand that you are actually constructing this one-to-one model, and they can quickly cross-check with your objectives while they are reading somewhere between the text before reaching the conclusions. It was also mentioned that every objective should be accompanied with a series of methodology, analysis, and to be concluded in conclusions. It shouldn't be a simple statement claiming what you want to achieve without further actions. Whichever you claim in the objective, it needs to be realized in your research design later. Maybe you are the first time being introduced with this model. Based on what I have explained just now, you might not be able to imagine it. Let me show you an example how this can be done. Taking this research as an example, the figure here demonstrates a flowchart of a research where the research starts with the problem and objectives. Then you will do a literature review, and then a preliminary study will be carried out. In this study, the experimental program was carried out. The research proceeded with the parametric studies, which was divided into 2 stages due to the numbers of parameters covered beyond the manageable level until you separate them into 2 stages. After the parametric study, you will proceed with the analytical model derivations. This is where you're going to derive equations to predict the response of your specimens. For the equations derivations, you will need to verify your model. There will be a checking against the experimental result, the reliability of your model. If the result shows that the model is not reliable, you will have to revisit the analytical model study, refine your model until you are able to produce reliable results. After that, you will proceed with the discussions and conclusions. And then your entire research completed. The flowchart here shows the stages of your research study, as well as the relationship between those stages. The first principles and fundamentals as acquired from the literature review will be used for the analytical derivations, as well as for the discussions of the results. As for the result and findings as acquired from the preliminary study and parametric studies, they will be used as the basis for you to derive the analytical model, and then the result will be used for verifications of the models. And then what you see here, the entire research design are meant to fulfill the three objectives as identified in your research. Let's say now your objective is to develop a design of something. In order to achieve this objective, you will require an extensive literature review in terms of all the possible designs which are existing available, as well as the concepts and principles which may be applied in your designs, knowing the governing factors that can influence the behavior of the intended design, and so on and so forth. Having those basic understanding, you may have an idea in terms of the new design. Now you would like to know whether your proposal is feasible. At this stage, you do not know whether your proposed design is actually workable. Is there any misunderstanding, or whether you overlook certain important parameters or conditions? This will need to be determined through the preliminary study. At this stage of the preliminary study, it is not a full investigation, as you are seeking for one single answer, whether the proposed design is workable. Therefore, your experimental program will be rather basic. Your analysis will also be quite basic, only focusing on the critical criteria. Let's say now after your preliminary study, you realize that none of your proposed design is workable. You will have to go back to the literature review, seeking for better understanding in terms of the concepts and principles, and come up with better design. The ultimate goal here is to make a design workable. As long as during this preliminary study you prove that your design can be used, your objective 1 is considered achieved, as your objective 1 is to develop a design of something. Now that you have come up with a design of the something, this design is still quite basic and not fully optimized. You would like to investigate further in terms of the behavior of the proposed design, particularly due to the changing parameters. That will be your second objective, to investigate the behavior of something. In fact, you can have only one parameter study, which in this case there are 2 stages of parametric study. This is because you have the parameters that you want to study of at least 4. You know that an ideal study that you want to see the effects of the parameters, which is at the manageable level, there will be about 2 to 3 parameters in a single stage. Imagine you have two parameters. You can plot your parameters design in two main axes, one vertical and one horizontal. For each axis of the parameters, you will require 3 points. This is so that you can observe the parabolic trend in terms of the changing parameters in each axis. Now that you have vertical and horizontal component, each directions you will have 3 items, and the other directions you will have 3 items. In total, you might need to construct 9 sets of specimens. And if your specimen is small enough that you can produce 3 specimens for 1 set, it is always a good practice for you, as you can acquire the average of the 3 as for the result from your experimental program. This leads to a situation of 3 times 9, a total of 27 specimens for 2 running parameters. Now let's say that you want to study 3 running parameters at the same time. Your axis now it will be in X, Y, and Z. Again, follow the rules that you need at least 3 points for each axis. Your total number of the specimen should theoretically equals to 54 specimens. The number of specimens will increase significantly when you have the 4 parameters running together. This will lead to these 54 specimens to be further multiplied by 3. That is the meaning that with the increasing numbers of the parameters, it is beyond the manageable levels. Of course, due to the limitations of some studies, especially when your specimen is rather big and expensive, it is not possible for you to have all the specimens, 3 in the set, and then a total of 54 specimens fully fabricated and tested in the laboratory. For example, when you need to test full-scale specimen, which you require a long time for you to fabricate the member, consuming a lot of funding, and for you to conduct the testing of the specimen, a long time is required for you to complete that. Some may choose to minimize the number of specimens. Instead of having 9 specimens, they choose to do in 3 along the line, which resulted in 5 specimens. Some might want to simplify further, not doing 3 identical specimens for each point. This can be further minimized into 5 specimens only. You know that with the significant reductions of the numbers of specimens, there is a risk for you of lower confidence level. If you have each parametric design only 1 specimen, any errors or mistakes or the defects which happens during the productions of your specimens may affect your data, and you might not be able to check the reliability of the results. These are all the things that you have to take into considerations while designing your parametric study. Now let us come back to this. Research design, which in this case you have 4 parameters to be studied. Therefore, you separate the parametric study into stage 1 and stage 2. Having 2 parameters studied in stage 1 and another 2 parameters studied at stage 2. The best design within the stage 1 will be brought forward to the stage 2 of the parametric study, which later is going to be the fixed variable in the stage 2. From here, you will be able to observe the changing and effects due to different parameters. Now that you have completed the experimental program, you have successfully developed a design which is workable, and then you have investigated the behavior of the design in terms of the changing parameters. You would like to translate it into something that can be used by the engineers. This is where you're going to start with your analytical model. You need to derive equations from the first principles on basis of the findings that you acquire or observations that you see from the experimental studies. While developing this equations model, the principles and governing parameters as implied by the equations model must be in line with the findings and the observations that you acquire from the experiment. This will serve as this cross-checking to your analytical model. You will need to make sure the principle as implied by the model is fully in line with the observations that you have for the experiment. Once reaching the intended outcome, which you have developed a model for you to predict a certain response, now you can put into the data as obtained from the experimental study for verification purpose. You can substitute the same parameters used in your parametric study into the equation model. There will be predicted result from the equation model. This predicted result is later to be compared against the responding variable as acquired from the parametric study 1 and 2, which is the result of the parametric study. Then you can quantify the reliability of the equations model as compared to your testing in your parametric study. How many percentage of the specimens are predicted with high level of accuracy, probably within plus minus 10%, and if the majority of the specimen, let's say now 80% of the specimen, have the predicted result within plus minus 10% as compared to the parametric studies, you know that your analytical model is more or less reliable. And this is the third objective that you would like to achieve, which is to derive equation models for you to predict certain response of the design. Once you have completed all this, there will be discussions and conclusions based on all the work that you have done throughout your research. What you see here is each objective should carry a significant part of the research. The meaning of significant part of the research is defined by two definitions. It carries a certain significant portions in terms of the stages of the research, where there is a complete set of methods, analysis result for every single objective. And then the second part, it will be those objectives cannot be simply omitted. Imagine you omit this objective 2. You will see that the entire research now is incomplete. None of these objectives is replaceable or omittable. That is the meaning of significance. Therefore, I would like to stress again, constructing an objective seems to be easy. It seems to be simply a statement, and we focus so much playing around with the usable keywords, particularly the verbs that can be used to define the objectives. You are also not to forget that The objectives are big deal in the research. Every single one of them are significant. They contribute significantly to your research and normally cannot be omitted. That is the reason that most of your supervisor and examiner, when they want to evaluate your research, definitely they will look into your objectives. They always look into your objectives, give comments to your objective, and also ask questions in order to dig further into your objectives. There is a reason for those. It is not merely just some sentences that you can simply claim for your research study.